Hi, I'm Bill Vantuono, Editor-in-Chief of Railway Age, and I'm with Peter Jones, who's Senior Vice President, Product Development at the Greenbrier Companies, and we are looking at a new advanced high-strength steel boxcar door that was developed for applications to avoid damage and improve reliability and availability of this equipment. So tell us about this, Peter.
Well, thanks, Bill. The advanced high-strength steel door is manufactured out of a grade 100 steel. This is essentially a steel that is twice as strong as the steels we typically use in railcar construction. It was specifically tailored to address loading and unloading issues where fork trucks can be backed into the door and create deformation and damage. So the entire door panels, the stiffeners, the door control rods are all out of significantly stronger steel. The idea is this steel won't yield in service and should give us a significantly longer service life of the door.
Now, as you were explaining earlier to me, a lot of the damage occurs from the inside of the boxcar when it's being loaded, and the issues show up later in service when the boxcar is at its next destination.
That's exactly right. We spent a lot of time analyzing the damage that occurs to doors, visiting repair shops, our repair records, visiting TTX shops, looking at the kinds of damage that there were on the door. And we observed that whilst we always look at the exterior damage, the root cause of the damage was exterior pushing on the door. And then the frustration of that deformed door creates problems of opening, and then the door damage gets transferred to the outside. So we looked at that situation. We believe we could have solved it by using high-strength steel for this door. So yes, absolutely.
And a characteristic of this steel is the strength. It's really elasticity, where it'll rebound if it's hit and deformed.
That's exactly right. So when I say grade 50 or grade 100, what that means is the yield point of the steel. So the door remains elastic up to that point. So we can have this door flex, deflect, absorb an impact, and then return to its original shape. And we have to put twice as much force into the door to result in permanent deformation.
So one term that's used here is KSI. Which is an indication of the strength of the steel. And how does that apply in this particular application here?
Okay. When I say grade 50 or grade 100, what that means is the yield point of this steel is either 50 KSI or 100 KSI. KSI is pounds per square inch. It's the amount of force that you need to apply to it to get to the yield point. And at yield, you permanently deform the steel.
So, being that the doors initially on a boxcar are sustained damage from the inside, can you describe what happens typically when you have a forklift operator delivering pallets inside the car and maneuvering in that
Absolutely
tight space?
So what we observed is the damage process to the boxcar door starts on the closed locked side of the door, not the open door. The operators tend to reverse their fork truck, and they index by hitting the locked door and then making a turn to either end of the boxcar, and they do the same as they rotate out. So they're always reversing in, hitting the closed locked door and moving around. And that's really what starts the damage process and makes the door much more difficult. However, you don't discover the damage is there to the door until the boxcar has gone through several turns and you now try to open the door that had been previously impacted. So you don't see the damage straight away. The frustration comes when the boxcar arrives at another location, the door is already deformed, and it is very hard to open in that case.
This boxcar that these doors are installed on, this is this particular one is a TTX T-box. It's a 60-foot plate F. How many cars of this are in service now being evaluated?
Okay, so we've had 5 cars running with Norfolk Southern in a closed service, which is a high damage service loop, for about a year. And we have another 5 cars just going into service now since July with TTX. So we're hoping to see the benefits of all the engineering we've done very soon.
Looking ahead, there is another type of steel which is ultra high strength, which is applied to cars, for example, working with Norfolk Southern on an ultra high strength steel gondola. Do you see in the future maybe possibly moving to that type of steel for depending upon how this pans out?
Absolutely. Greenbrier and Norfolk Southern have been on a journey for several years now, exploring the use of these advanced and ultra-high-strength steels. We're just about to ship production versions of the ultra-high-strength gondolas to them. We're waiting to see if we've done enough with the advanced high-strength steel. If there's still damage occurring, we have the ability to switch to an ultra-high-strength boxcar door very easily. But at this point, we think doubling the strength may be sufficient for the kind of loading and unloading damage we see in boxcars. So we're ready to go with that, but I'd like to see a little bit more field service on the advanced high strength.
So I'm also here with Tyler Chambers, who is Director of Product Development at the Greenbrier companies. And Tyler, can you describe what does this equipment see in service every day? And it has been in service for quite some time. What has it been experiencing?
Well, typically our boxcars will experience quite a bit of damage to the doors during the unloading and loading process. A lot of times the forklift drivers will back up into the door, index off of it, turn, and unload. From there, then they'll go back, index off the door again, and that damage ends up creating quite a bit of deflection in the door to where when later down the road, when they try to open the door, it won't work. So the idea is with our advanced high strength steel, we're now using a grade steel that's grade 100 versus grade 50. And that really makes it to where we're much more elastic. So whenever the forklift driver does back up and hit the door, it now rebounds back to the original shape so that whenever down the road we go to open the door, we have no issues.
Right, and these forklifts typically weigh about 15,000 pounds. So when you say indexing, that's a polite way of saying hitting it. And maybe you might be, as a forklift driver, and I've never driven one for the record, if you hit, that's a lot of force, even at a very, very low speed. And from what I understand, you will hit somewhere down in this area, right, but that is going to throw the locking mechanism out of alignment. And over a period of time, you do that continuously, and then all of a sudden, hey, this door will not close or it will not open.
That's correct. We see quite a bit of force coming from the forklift driver, even at low speeds. So like I said before, whenever we have the doors at grade 50, that's 50,000 pounds of force that it can stand at the yield point. These doors with advanced high strength steel will be 100,000 pounds of force. So that's double the capacity of yield for it to be able to withstand from a forklift driver.
So far in service, and it's been about a year roughly with Norfolk Southern, what have the results been so far?
Well, Norfolk Southern's been great, and they've put these cars in a closed loop that typically experiences a high amount of damage to the doors, and so far we've seen no damage to our doors.
So over a year worth of service, how many turns per month does a boxcar like this make on Norfolk Southern? What have you been observing?
So we've seen it's about 5 turns a month, so that'd be about 60 turns over the course of that year.
And that's a lot of opportunity for impacts and some serious damage.
That's correct. That's quite a bit of opportunity, and so far we've seen no damage.
Well, those are certainly excellent results, and we will be tracking this as this program progresses. And the boxcar that these doors are installed on is a 60-foot Plate F T-box car built for TTX. And there are 5 in service right now at Norfolk Southern, and there's another 5 in service on TTX. This particular one is built for TTX.
That's correct.
Okay. And we'll be tracking this and reporting on the results. Tyler, thanks so much for joining us, and thank you also to Peter Jones for joining us on this.